Okay. So far we've been, if you've been playing around with Java and following the learning Java track, you've been sort of compiling and running Java and using an IDE. If you've been following the sort of Oracle track, you've been using Netbeans, and that's the sort of application I'll use a little bit later this morning. But the first thing I want to do is think about a build tool. So one of the problems that a build tool can help solve is having to manually compile and then run a program. And so we can speed up that process and sort of automate it. So when we talk about build tools, and the main ones so far that you'll sort of hear a lot about when we work with Java are two build tools called Maven and Gradle. And for the purposes of this morning and for the rest of this course, we're going to be using Gradle, but at the end of the day, both do fairly similar things. They're both trying to help automate the process of compiling and building and just like running some of the tasks of creating and running a Java application. The question, therefore, is like, how do we install it, how do we run it, and how do we use it? So that's what I wanted to demonstrate with everyone today. The first thing to do is install it. So go find a installer. You can Google sort of Gradle and go to the Gradle website and figure out what platform you're on and install the right installation. And once you've installed it, you'll have access to.
Can you record it? Oh, it's recorded.
So I just want to, Jamie, do you want to just say it again, just so I get the satisfaction of you realizing that again?
What, that you're recording?
Yeah, exactly.
Yeah, I know, it's dangerous, isn't it?
I did remember this time. Once you've installed it, you should have access to it. And it gets installed, and I have access to a Gradle command. By default, if you're on Mac OS, all your sort of executable files get stored in your binary folder, bin folder in user local. Which means I can run it. I have a Gradle command that I can run, but I need to pass it certain arguments. So whenever starting an application, you can initialize a project. So think of it in the same way. It's a little bit similar to the dependency managing tools that we've been using with Node.js. Think of it as the same as doing npm init. This initializes a project. So you can run Gradle init, and it tells you, it asks you like things that you want to do. But I actually want to not do it in this folder because I've now just initialized it in entirely the wrong place. Let's just delete that, and this other one. We'll have a look at this in a second. What things get created? So let's create a folder. Let's do Fizzbuzz just as a name of a folder. I'm going to move into it and run initialize the project within my directory. So this should be fairly sort of easy to transfer your knowledge of using npm init onto this project. They are different tools, and so Gradle does a lot more than just manage your dependencies. Select type of project to generate. So let's do application to begin with. An application has a main function that we can run, and let's do that for the moment. And we're going to do a Java project. So notice that there's a few different options that you can use Gradle straight out with. You can use this build tool to help automate a bunch of tasks for creating programs in these different languages. It's not only these languages, you have a few more if you wanted. but we're using Java, so let's choose option 3. And I'm only going to have one application project. Select the build scripts domain-specific language. It doesn't really matter at the end of the day. Usually default, let's choose 1 for Groovy. It's a more concise version of Java. Select test framework. Let's use JUnit 4 by default as a common test framework for Java. Project name. Yep, Fizzbuzz, I'm going to keep the same. It has the default of the directory, and the source package, I'm happy to keep it the same as well. Cool. So you can see here that it's actually run a task straight away, the sort of initialize task, and that it was successful. So let's have a look at what was created when we ran this command. So we have a bunch of things here that are important. The first thing is this Gradle W file. So this is mostly for the purpose of when we're running a Gradle manually. So this is like without an IDE. And the reason why I'm introducing this without the IDE first is just so we get a sense of what Gradle is actually used for. And then when we see it, when we start a new project in an IDE like Netbeans, we'll have more of a sense of how the IDE works and some of the steps that it takes. So we're going to use, given that we've installed on your machine, we've installed it globally, we have access to Gradle wherever. We want to make sure that from this point onwards, after you run Gradle on it, you use the wrapper, and the W stands for wrapper. It just makes sure that you use the sort of the Gradle version specifically according to your project. So if I wanted to run my project, I could run it from the file Gradle W. Let me make this a little bit bigger up here. So the same thing would happen if I use Gradle just straight away like this, but the convention is to use the wrapper because it's specific to the project. So you have multiple projects, you're using the Gradle specifically for that project, the version of it. So we'll have a look at using that command in a second. Let's explore what else has happened in this sort of setup. We have an app folder, and this is where commonly you'll see your sort of source folder where you write all your main Java, and it's separated into 2 folders, main and test. And we'll write our code in this package. So it already has some starting sort of boilerplate code for you, and we're going to run this and see what happens. We have a main app class with a sort of main function that just prints out the result of this instance calling getGreeting. So we should see hello world. It prints out the return value of this. So how do we run it? Well, normally you'd have to compile it first if you're doing this manually, and then run the application. And if we're using Gradle, we can use the run task and get it to do everything for us. So you can see here a few things happened. It's created a build directory here. This is the compile stage where it threw everything into this folder, and this is where it runs from. So you can see here it's run and outputted my application to hello world. So quite a little bit more straightforward, having to compile it, find the class name, or find the Java file first, find the class name when you want to run it. It's a little bit more simplified. We can automate some of those tasks. And the steps that I just did was, well, all I did was use Gradle init to create the project, cycle through some options, and then Gradle run. Correspondingly, we have some tests here. We have a test that got generated automatically, and we can run the tests using Gradle as well. because everything's happened straightforwardly automatically during the setup to initialize it with the dependencies for the test framework. All we now have to do is run the lifecycle task for Gradle using test. So the interesting thing about when we run the test, just bare bones at the moment, it doesn't really show us any output. It just shows us that it's a successful execution of the task. And so there's a couple things that when you move to your Netbeans application, that gets sort of added to it. And we can do a little bit of this manually. And the way that we want to update any of these sort of lifecycle tasks is in this file called build.gradle. This gives some information about what needs to happen. Now, I don't really want to worry too much about this this week, maybe even next week. But if we're doing this manually for now, which we won't do, we're going to move to using a Netbeans or any other IDE, which will do this for you. We've got to add some information here to sort of help us show some output. This is what we're going to add, and I'm going to share this file, and I just want you to not really worry about it. But this is some of the things that your Netbeans application or your application will do inherently to help give you more information about what your tests have done. So I'll show this in the code in a second, but we're going to take this sort of set of instructions and we're going to put it at the bottom of our build file. And make sure we have the packages that we need. I'm going to put this put here. And this adds some packages from dependencies to help us sort of create better test output, so we can actually see it when we run our tests. I'm going to recompile it just to make sure that it's working. Cool. All right. So you can see I get a little bit more information now about my test, that I have an app test and it's passed. If I want to fail it, you can assert not null and maybe just write this as null. Cool. So it says it's failed, and we have a sort of a test failure. It's saying that it should be null, but it's not, because I mentioned it explicitly. So gives us a little bit more output, so we can see it when you're doing it manually. So this kind of approach gives us some test output that we can read and understand our tests. Out of the box, Gradle doesn't have support for this, and it's by design, so you add in what you want. So when you move on to using it in your IDE, it already has some version of this, and it has a few more things that we'll have a look at in a second to help visualize some of these tests. So this is where I'm going to stop for the moment, and I'm going to sort of like throw it back to everyone to like have a go at this, and then I want to explore doing the same thing but using an IDE. So what I want you to do is be able to install Gradle manually, use GradleNet to create a project, and use those two tasks to run the application and then test the application. And for that, you have to, if you want to see the output, you'll add those lines to your build Gradle file. That's what I want everyone to do. Sound good? Any questions before you start? It shouldn't take that long. It should take about maybe 10 to 15 minutes. You might run into some errors, which will always slow things down. So let's gather back at 10:45. And for this first exercise, let's just do it solo. And have a go creating a project using Gradle, installing Gradle, creating a project using Gradle, and then using those two lifecycle tasks, run and test. I will share the snippet of code to add to your build Gradle file. Pause and pause. Cool. So in front of you should be able to see the IDE that I'm using. So I recommend using Netbeans, or I guess the main ones are IntelliJ and what other ones? Eclipse probably are the main sort of IDEs that we use for these kinds of this kind of development. And they all work in roughly the same way. All right, we also add projects, and they help automate some of these tasks, and give us a way to sort of remove the need to write a lot of sort of boilerplate code to create applications. So let's start off creating or opening up a new project. So let's start a project, and you can see here that it comes with Gradle. So when we do this, it creates an installation with this build tool, which helps us. So let's create a jar application, and let's go next. So I'm going to name this one. I guess let's call it demo. I'm going to keep the package name the same as I was doing before, but just creating a new project. It's going to be in the same folder that I'm working in at the moment. That should be fine. Cool. So notice in the IDE we have a way to run our programs, and this is using the same kind of task that you ran manually on your command line. It runs the project. At the moment, there's nothing here, so I've got to sort of probably write something for this to make sense. So let's quickly write this then. Let's at some point let's create a Fizzbuzz instance of a class, and what I just want to do with this, let's just be super simple about it. I'm going to just do one number. Let's keep it quite straightforward. Let's write a method play for a Fizzbuzz class, and just so it prints out what is the Fizzbuzz value for play. So in order to do this, I need to add a class, and so I can right-click my directory and add a class. I want to call this Fizzbuzz, and fine. It gives me some sort of default values for this, and I'm going to have a some kind of play method that has a number. And in this is where you put the classic sort of if statement. If number is divisible by 15, let's do a very simple implementation of this. If the number is divisible by 5, we all did this yesterday, so else if number is divisible by 3, and the last condition is if it doesn't meet any of those first three conditions. If it's 15, what do we want to return? We need to make sure we have return statements. It's going to be some kind of string. Let's do Fizzbuzz. If it's divisible by 5, it's going to be buzz. Why is it always indent so much? It's going to be fizz, and here it's going to be some kind of. Oh, yes, that's fine. Okay. So I've got an instance where I have a class of Fizzbuzz, and it has a public method. So this is this will help us sort of run our program, where we use our sort of main function in our application to run it. It creates an instance of Fizzbuzz and then prints out the result. So when we click the run button, it's going to go through that task where it sort of compiles it all and then runs it. As you can see here, in the output down here is the output of like running Gradle, and you can see here in one of the commands that it actually uses the Gradle wrapper to run the command, and it has this run here. There's a few other things it does to help, but the main task it runs is this run command. So that's sort of been automated for you using the IDE. In the same way that we can ideally sort of test our sort of Fizzbuzz class. So if you go to the file, go to tools and create, you can create a test for it. And this is going to be a lot easier than having to remember and manually run everything else yourself. In some of the other sort of programming languages we've been doing so far. So click a few options and it sort of manages it for you. Let's have a look at what happens. So this gets generated in my test folder. I have a Fizzbuzz test here, and it organizes your code for you. So make sure you're in the same package, so it has access to the class under test that you need, imports all of your test dependencies from JUnit, and gives you like the outline of a test. The class that we're using to create the test is called Fizzbuzz test. And it's got sort of generated constructor if we need it, and it's got these two sort of methods that I enabled in the options when I created the test. This is familiar to you if you think back to using Node.js or the JavaScript in the browser that we're doing. There's like a before each and a way to sort of make sure we do some setup before a test, and also after. We don't really need the after for the moment. But if we wanted to dry out this test or move some of the setup, we can move it into this method. So this gives us a test that I can play around with. It's not, I don't need to output that, and you can sort of remove some of these generated code for you if you wanted to like deselect all those options. When you right click and create a test, you can just deselect everything and write it manually, or edit it as you want. So really what I want is just to create an instance, and let's say I'm testing a certain number, and I want to do 5. And then I make my assertion. So maybe that's the test that I want. Create an instance of Fizzbuzz. I want when I call play 5 on my Fizzbuzz instance, it should be buzz. So how do I run this test? in the same way we've been doing so far, I can run this file and see the generated output. I can run my class here. I can have a look at the output, and in my test file, if I call test, it can run the task for me. So this will help run the test for me. So I can see both the run task and the test task. And you can see it still runs using Gradle, because that's how we've configured it. And it runs the test. The sort of output is usually it shows up as output. Open test variant. There we are. Cool. So this is usually the output that gets shown from running the test, which is nice to see. And you can see the sort of test result here. Yeah, it passed. Let's have a look at the failure. If I did something like Fizz and rerun the test, I get a failure, and that's helpful to see. If I have a look here at the sort of index.html, this gives me a nice view, and it generates in the build directory. And I can get like a nicer view of seeing all my tests. So you can have a look at the test failure and have a look at this lovely exception that gives me information about expected fizz, but got buzz. And it shows me sort of the similarity. Like these are the two things that are different, but the Zs are the same. Yay, I'm halfway there. So this gives you a nice like interface to your test, and part of the problem this solves is notoriously sort of exceptions in an IDE are not very easy to read, or even the test failures. So this is helping you give like a useful view on this. It's all just HTML. So if you have a look at your which one am I in? I think am I in demo? I'm in demo. There's going to be some kind of, where is it? Where did it get generated? Reports, build, reports, tests, test, index.html. So this is the view that you see. It's just got a bunch of HTML that gets generated and shows you this view. So it's just it just helps give you the view after it's run the test. And gives you some information. So if I wanted to go back and parse it, let's go back to Buzz and rerun the test. And then I have to refresh the page. Got a nice parsing test here. So this gives you a little bit more quick and useful feedback, so you don't have to keep scrolling through tiny little boxes on your IDE to make them bigger. I recommend using this view or some HTML view so you can have a look at your tests and see them organized. Cool. So this is what I wanted to be able to demonstrate is having gone through looking at Gradle on the command line, looking at the problem it helps solve, which is automating some of these common tasks when creating and developing a Java application, having to compile, having to run, having to keep rerunning your application. So you have to keep recompiling all your files and all your classes. And then being able to test your application as well. Cool. So let's throw it back to you. Have a go at doing the same thing. Create a new project in your IDE using Gradle and setting it up accordingly with a Fizzbuzz, a very simple Fizzbuzz game that you can run and test in your IDE and have some kind of useful test view depending on which IDE you're using. Does that sound good? And then we'll come back and Q&A how we found it. Cool. Any questions before you disappear again for 15, 20 minutes? Susanna and Marie, have you already installed an IDE?
Yes, I've got IntelliJ.
Cool. Marie?
Yes.
Cool. All right. So the installation process you shouldn't have to worry about waiting for Gradle to install that. Cool. All right.
I have a question.
Yes, go ahead.
Do we have to use these IDs if we don't want to?
No, you don't. No, it's absolutely fine. The one thing that might be useful to make sure you're familiar with, and I'll need to double check what the sort of Java cert for the associate level is. There might be some Netbeans questions in it, but I imagine I need to double check. But that'll be the only reason why you would need to use that specific one. I'm doing it because it's the default. Everyone's probably familiar with it. It's fine. Yeah. Tools are best when you choose them yourself. So if you enjoy another tool, absolutely use it. No problem. As long as it's close enough in what we're doing. All right. Let's gather back at let's do 15 minutes again. I'll do a quick check in Discord about if we need more time. Cool. See you then.